This is Startalk. Welcome to Startalk. I'm your host, Neil deGrasse Tyson, your personal astrophysicist. And we're recording this out of the world headquarters of Mashable, right here in New York City. And today we're going to tell you everything you ever wanted to know, and perhaps what you didn't even want to know, about the upcoming great American Eclipse. American Eclipse. Co-host is Chuck Nice.
Hey, buddy.
Chuck, love you, man.
Love you too, man.
And he also hosts a spin-off of Startalk, Playing with Science.
That's correct. Playing with Science. That's right.
When you play with science, I should. Did you get permission to play with science?
Has your mother caught you playing with science, Chuck? Hey, there's a lock on that door for a reason.
Don't you know I can make you go blind? So just to remind you, because I'm not in that show.
So no, Playing with Science is Gary O'Reilly, who is a former footballer, and Chuck Nice, who is some guy. And we actually have different athletes on the show, and we take what somebody says where jocks and geeks collide without a concussion. Without a concussion. It's amazing. And so what we do is we take sports and science, and we break down the science in the sports, and we discuss the sports as well. It's a lot of fun.
That's a recent spinoff. That's why I'm still learning about what you guys cooked up over there. So, but thanks for joining us. Absolutely. And you know what we have today? By video call, we have an expert guest. He's my friend and colleague and an associate at the Hayden Planetarium, Joe Rayo. Joe, thanks for being on. Just to get some of your background here, you're a broadcast meteorologist, and you wrote the children's book, Looking Up, The Science of Stargazing. And so,
absolutely.
Yeah. It's good to have you. Always good to get your input on nighttime cosmic phenomena. In this case, it would be daytime phenomena. Yeah. And in particular, this episode of Startalk is officially designated a Cosmic Queries just on the eclipse.
Just on the eclipse.
Yeah. So we'll go to Cosmic Queries intermittently, but I want to get sort of Joe in the mix here. Joe, I've seen one eclipse in my life. You've seen some uncountable number of eclipses. How many total minutes of totality have you been steeped in?
Wow. I have seen 11. This will be, I'll make it an even dozen with the upcoming Great American Eclipse. And, that number may sound very impressive to a lot of your viewers, Neil, but and it was impressive 40 years ago, but there are people out there who have seen far many more than I have. There's some people who have seen 20, 25. And in fact, a friend I grew up with in the Bronx, your favorite borough, my friend Glenn Schneider, he has seen 33. This will be his 34th eclipse of the sun. So,
okay, next time we'll ask them to come on the show.
Well, I've always said total eclipses, when you see it first, it's like potato chips. You become addicted. You have to have more. And quite obviously, I've been addicted because I've seen 11. This will be my 12th, and I hope to see a lot more before I depart this earth.
Well, I'll be going media silent during the eclipse, which will force the media into the thousands of people who walk this land, right, who have expertise sufficient to deliver an interview with the press.
But you know they're still going to call you.
I know.
You know that, right? Seriously.
No, because they get lazy and just call me because I live here in New York City,
right, and
they know I can give them a soundbite. But this event will sell itself, and so that's why I don't need to be there. And my location is a state secret.
Oh, really?
You will not know where I am on Earth.
Where are you going to be?
You'll know I'll be in the path of totality, but you won't know where I am on Earth or my elevation above Earth.
And you know what's funny is I get asked every day on Twitter where you are going to go watch the eclipse, and to which
And in case you get tortured, I don't want you to know.
Right. Well, I tell people all the time, Neil doesn't like me. He tells me nothing. We just work together. What is your problem?
So, Joe, I'm looking at that's your office in the back there with all these degrees on the wall. So Joe's wicked smart.
Yeah.
And you got a total eclipse in the upper corner there, or is that a black hole?
No, that's a view of a total eclipse of the sun. I don't know exactly. Actually, I have a total eclipse, an annular eclipse, and I have an eclipse that was taken by a gentleman from the Amateur Astronomers Association right here in New York. He is no longer with us. That dates back to 1945 over Montana. The rising sun over the hills of Montana It's a crescent sun, and a few minutes after sunrise, it went into total eclipse.
Wow.
And they're amazing, Neil.
That is
of course, you've
gorgeous.
seen it.
That you can't beat that. It's like the sunrise, or is it nature's way of saying, I just robbed you of a sunrise?
That's right.
It's interesting. The next total eclipse of the sun over little old New York will be on Tuesday, May 1st, 2079, and that happens right after the sun comes up. So if it's clear that morning, it'll be probably the most unusual sunrise in New York history. Again, if it happens to be clear.
He's speaking that like we're all going to be alive.
2079. I'll be sure to mark my calendar.
Put that on my smartphone now. So, Joe, spend a minute just describing what the hell is going to happen.
Well, actually, at the very beginning, you don't even know that it's happening. If you're not aware that there's an eclipse that is going to take place, a total eclipse of the sun, what happens is that the moon begins to move in front of the sun. And actually, you have to have a considerable amount of the sun covered before you start noticing that something eerie is happening. The landscape, after about 70 or 80% of coverage, the landscape begins to take on kind of a weird look, more of a yellowish color, almost like a dusky twilight beginning to descend upon the entire region. But it's not until that last 30 seconds, before totality, that it really gets crazy. It's almost like being at a Broadway play, curtain time at a Broadway play. And if you've been to a Broadway play, they lower the lights very quickly just as the show is about to begin. That's kind of like what it is just before totality. All of a sudden, the sky begins to darken very quickly. And then suddenly, up in the sky where there was once a brilliant ball of light, the sun, you now have this strange eye, if you will, rimmed with fire appearing in the middle of the sky. And stars come out. The sky gets a quality similar to twilight, half an hour or 45 minutes after sundown. And it's just an awesome, awesome spectacle. And it only lasts for, depending upon where you are in the eclipse path, only about a minute or two. In this case, at most 2 minutes and 40 seconds. And then after that, we just reverse the procedure. In 30 seconds, up comes the lights. And within a minute or two, it's almost as if nothing had happened prior. It's back to a normal sunny day. And it floors everybody who sees it for the first time. And I think a lot of people are going to be just stunned about what's going to occur on August 21st that streaks across the United States from coast to coast.
So, Joe, I hadn't appreciated this until you just said it now. There's nothing in life experience that darkens a daytime sky as quickly as the last few seconds of the partial phases of a total eclipse. Because when the sun sets, it's slightly darker, but it's not pitch black.
Right.
And some people think it gets immediately dark at sunset because they've never paid attention.
Exactly.
Right. I've had lawyers call me up and say someone is testifying that they couldn't see anything when they were driving because it was 5 minutes after sunset. I said, there's a line. So here we have an eclipse where a few percent of the sun exposed is sufficient to just be kind of bright daylight, and then bam, darkness descends upon the deep.
A lot of people say, what's the big difference? I'm going to see a 95 or 97% partial eclipse. Is there really the necessity to get into the zone where it's going to be total? And my answer to that is most unequivocally, yes. Yes, you do want to get into the total band of totality, because if you don't, you're going to miss out on a lot. People are amazed. Even as you just mentioned, Neil, the final couple of percent of sunlight, even if it's a razor-thin crescent, still puts out a large amount of sunlight, a large amount of illumination. You got to shut off every little bit of the sun in order to appreciate just how much darker it gets. And with that few percentage points of sunlight remaining, you don't see the stars come out. You don't get that dramatic sunset and sunrise color rimming the horizon, and you don't see that shadow, the lunar shadow, come sweeping in and over you like somebody throwing a blanket over your head. You really miss out unless you get into that zone of totality, and I think that's going to lead to a tremendous number of people trying to do that on Monday, the 21st of August.
So it's been said once, and I forgot who said it, and I'm going to have to paraphrase it. Mm-hmm. So it's the difference between seeing a partial eclipse and seeing a total eclipse is equivalent to the difference between kissing your loved one and having sex with your loved one.
I love this analogy.
because they're both pleasing.
They're both pleasing.
But
I'll take either one.
You cannot extrapolate
Right.
from the kiss to sex. There's no path to land there.
Right.
It is it's completely more.
Absolutely. Absolutely.
It's here.
Yes, exactly. It is right. Yeah. Yeah, exactly. One is like eating the best, most exotic delicacy you could ever find, and the other is like licking carpet. So
no, licking carpet is unpleasant.
Yeah, that's true. They both have to be good. They both have to be good.
That's why this analogy was good.
This analogy was good. I just screwed it up.
You just messed up badly.
How about being outside? You before World Series, seeing a partial eclipse is like being in the parking lot. Seeing a total eclipse is taking your ticket, walking into the stadium, and sitting down in the box seat and getting ready to actually watch physically the game.
And
it's both exciting.
And then having sex in the seventh inning stretch. There you go.
There you go.
Now we got
There's a total eclipse for you.
Total eclipse.
What makes this America's eclipse?
It's being called the Great American Eclipse because, number one, it's the first time since 1918 that this eclipse is going to be going from coast to coast. In 1918, we had one that came in from the Pacific coast and went across the United States, ended up going through Florida, exiting out over the Bahamas in 1918. So that wasn't a full American eclipse because it did touch places outside of American soil. This one is being called the Great American Eclipse because we're the only country. We are the host of this eclipse. There have been other eclipses in the past, like, for example, in 1970, there was one that went through Mexico, went up along the eastern seaboard of the United States, and then went into eastern Canada, the Maritimes. 1979 swept over the Pacific.
That 1970 eclipse, that was the Carly Simon eclipse, correct?
No, I think the Carly Simon eclipse was 1972, actually.
Oh, excuse me.
It could have been the 1970 eclipse. It could have been the 1970. Believe it or not,
you guys can't go any further now. You just have to. The Carly Simon eclipse? What, is that an eclipse that looks at you and says, like, oh, you think this is about you?
Well, you know the song.
What kind of eclipse? What's the Carly Simon eclipse?
Okay, Joe, explain.
You're so vain, right? Yeah. Right? The song, the Carly Simon song, You're So Vain, and she apparently writes about somebody, some mysterious person, who went to fly his Learjet to Nova Scotia to see a total eclipse of the sun.
It's a lyric
in the song.
Yeah.
Oh, okay.
Yeah.
That could have been one of three eclipses. There was one over Nova Scotia in 1963. There was one in 1970. I personally think it was the one in 1972, July. That was also my very first total eclipse. I saw that one from Quebec, but after it passed over me in Quebec, it went across Nova Scotia. And I think the song, Carly Simon's song, was a hit the following year in 1973, which makes me think that maybe she was talking about that 1972, or maybe she was just making the whole thing up. Who knows?
No, the song's about Ned Beatty, I think. So,
Ned Beatty?
No, I'm sorry, Warren Beatty.
These are two different Beattys.
Yeah, nobody would ever write a song about Ned Beatty. What the heck is my problem?
This eclipse is going to be the Great American Eclipse because we are the host country. There is no other country that we're sharing this eclipse with. And the last time that happened was before this country became a country. If you go back over the various manuals that show you tracks of past eclipses, historical eclipses, the last time this country, if you use the political boundaries, had an eclipse all to its own was back in the year 1245 AD. So, and that was, of course, before the United States existed. So this is the very first time that we are the sole country, and there are countries, people from all over the world that are going to be converging on just the United States for this great American eclipse.
It's just one more way that we're making America great again. Okay. I'm taking total credit for this eclipse.
Okay.
By the way, did either of you know that Donald Trump, President Donald Trump, was born on the day of an eclipse?
That makes sense.
He was born on the day.
That makes sense.
He was born on the day of a total eclipse of the moon. Donald Trump. I haven't had a chance to look and see if any other president has had a total eclipse or any eclipse on his birth day, but Donald Trump has that recognition of being born on the day when there was a total eclipse of the moon.
Just to be clear, an eclipse of the moon takes place at the moon.
Right.
An eclipse of the sun takes place at the Earth. So if you are anywhere on the side of the Earth that sees the moon being eclipsed, you will see the total eclipse of the moon.
Okay.
Gotcha. So that's a lot of people that it could be.
That could, absolutely.
So it's not as rare a thing
Right.
to be born under an eclipsing moon as it is to be born under eclipsing sun.
Either way, I'm so great, I block out the sun.
So Joe, so what's an average totality among eclipses relative to this one?
Well, I mean, I think even just a 1 second total eclipse is more amazing than anything that you'll ever see in terms of a partial eclipse. And this one actually, I've been telling people, this is actually the appetizer, this upcoming eclipse this year, because there's going to be another total eclipse over the United States in 2024, only 7 years down the road. And that eclipse is going to be better in the sense that the path, the area of visibility of the total phase of the eclipse is going to be bigger. As I mentioned earlier, this one is not going to last longer than 2 minutes and 40 seconds. The one in 2024 is going to last in some places over 4 minutes. So whereas people will probably get turned on when they see this eclipse in 2017, and the first thing out of their mouths will say, when can I see another one? 7 years from now, in 2024, you'll get another one, and that one will be even better, much better, in fact, in terms of circumstances than what we're going to see this year in 2017. So
you get these differences because of the distance that the moon is from Earth is not constant. So
is that because it's like, so what would you call it? Is it like a depth of field when you're looking at something from a distance and you're like, you use your thumb to block it out, that type of deal?
Yeah, okay, but so if the moon is close, in the moon's elliptical orbit around the Earth, if we get an eclipse when the moon is closer to Earth, then the moon is bigger in the sky.
Right.
And if at that time we are farther from the sun, because our orbit around the sun is also elliptical.
Correct.
So the eclipse that I saw way back when had the moon at one of its closest times to Earth and Earth at one of its farthest distances from the sun. So it took a long time for the sun, for the moon to pass in front of the sun.
So, okay, gotcha.
So my eclipse at peak was 7 minutes and 14 seconds.
Oh my God. That is amazing.
Yeah, so that's at peak, but we couldn't go to where it was peaking because there was a dust storm kicking up over the Sahara. Okay, and so we saw it more off the coast. So mine was 6 minutes and 20 seconds.
Speaking of which, and since Joe is a meteorologist, is there a place where you don't want to go because if it's cloudy, you are screwed?
We will touch on that when we come back from this commercial break on Startalk.
Hey, everybody, just reminding you that everything that we do can be found on StartalkAllAccess.com, even things that can't be found anywhere else, like exclusive original content. So make sure you go to StartalkAllAccess.com and subscribe.
We're back on Startalk. I'm Neil deGrasse Tyson. Chuck Nice.
Hey.
Tweeting at Chuck Nice Comic.
Thank you, sir. Yes.
Love you, man, on Twitter. We've got with us on video call the one, the only, the guy who knows the nice guy better than anyone I've ever met, Joe Rayo, an associate at the Hayden Planetarium. And he's a meteorologist, he's like lifetime television meteorologist.
Yeah.
He's got that meteorologist voice, too.
He does.
Let me hear some of that voice, Joe.
This morning for breakfast, I had some eggs vorticity.
Very good. Okay.
Very nice.
So just before the break, we were trying to understand a couple of things. Well, let me back up for a minute. Today, people travel with much greater ease than at any time in the history of eclipses. So is it possible that this eclipse will be the most watched ever in the history of civilization? Because this is America and everybody's got a car.
Right.
And if you don't drive, you'll have a plane or whatever. And we all will just gather in this path of totality, this narrow path across the country.
Well, Neil, there are 12 million people who already fortuitously live in the zone of totality, the path of totality.
Yeah, exactly.
It's 70 miles wide. It's 2,500 miles long, stretching from Oregon to South Carolina. However, there are an estimated 220 million people. That's more than 2/3 of the total population of the United States. 220 million are within a 1 day's drive, 500 miles, of the total eclipse path, which leads one to wonder just how many people, either late that Sunday night, the night before, or early that Monday morning, the 21st of August, are going to suddenly decide, hey, let's jump in the car and go and see that total eclipse. So it's going to be interesting to see. There are a lot of, in fact, of the 14 states that are in the totality zone, the DOT, the Department of Traffic, has issued in all of those states warnings as if it were almost like a Category 3 hurricane heading in their direction. They are warning about major traffic jams. Stock up on food because you're going to be in your car for a long time. Wow. And even on some of the major interstate roads like I-85 in Georgia or I-5 in Oregon, they're anticipating traffic tie-ups that they have never seen before for all of these people trying to jockey into position to see the total eclipse that day.
So it's possible that 200 million people will see this eclipse. Do you think that that's more than any previous eclipse has ever been witnessed?
I'm not sure. I know that in 1991,
that's the Mexico City eclipse.
For that eclipse, the 1991 eclipse was related to the one that you saw, Neil, back in the 70s.
The same Saros,
a very long eclipse. Yeah, it was about 7 minutes long. It passed over Mexico City. The entire population of Mexico City was treated to a total eclipse, and I believe at that time the population of Mexico City in one sitting was like 23 million people.
Wow.
So it may not be necessarily in one sitting for this eclipse, but certainly if a lot of people travel into the totality path, this could very well be indeed the most viewed eclipse, total eclipse in modern history.
No, in all of history.
In all history.
Yes. And if I remember, the 1991 eclipse also went across Mauna Kea, Hawaii. And the telescope was able to observe it from there. Wasn't that the same eclipse?
Yeah, in fact, it passed over the big island of Hawaii, and Mauna Kea is there on the top of that extinct volcanic cone. The problem was they saw it at Mauna Kea, but all the people who went to Hawaii to see that eclipse, or most of the people who went to Hawaii, didn't. Prior to the eclipse, the meteorologists and climatologists said, there's a 95% chance of clear weather for the eclipse. Because in July, that was the month that the eclipse occurred, they get the trade winds, and when the trade winds blow, usually the weather is clear.
Absolutely.
But unfortunately, on the day of the eclipse, it was the other 5%. There was some sort of disturbance which clouded things over, and people actually got rained on in Hawaii. One person actually walked away after the eclipse and said the total eclipse was a total bust, at least for Hawaiians. So they were lucky that they didn't see it from Mauna Kea.
Yeah.
They're going to blame you, Joe. You know that, right? They're all going to blame you.
Well, you could look at all the weather records. You could see where the best place is based upon long-term records, but it doesn't always work out that way. In fact, Robert Heinlein, who was a very famous science fiction writer, once said, and it's absolutely true, climate is what you expect, but weather is what you get. So you may be in a place where the climatology says it'll be great for viewing the eclipse, but the weather makes up its own mind. If it decides to be cloudy that day and you don't see it, so goes.
Okay.
So before we get to Cosmic Queries, because this is a Cosmic Queries edition, Joe, spend a minute explaining what we mean by families of eclipses and how there can be a series of eclipses that are all related to one another.
There is a family or cycle that was known to the ancient Chaldeans and Babylonians thousands of years ago, known as the Saros cycle. And what this is that there are three different lunar cycles that seem to come together. It's kind of like hitting the jackpot, let's say, on a slot machine. These three cycles involve the position of the moon in its orbit relative to the Earth, whether it's closer or farther away, the lunar month, also known as the synodic month. These cycles all come together, and it's called the Saros cycle. Saros means repetition, and eclipses repeat after about 18 years and 10 or 11 and 1/3 days. That 1/3 of a day is important, however, because when the eclipse returns after 18 some odd years, the Earth in that 1/3 of a day has turned 120 degrees in its rotation cycle. And so while the eclipse is going to return, it will not return to the same part of the world that it was seen 18 years previous. this eclipse coming up, for example, the Great American Eclipse, 18 years ago, 18 years and about 11 and a third days ago, that eclipse occurred over Europe. Well, now 18 years later, 18 years and 10 and a third days later, the Earth has turned 120 degrees. So now it's not over Europe. This time it's our turn here in the United States or North America to see that eclipse. And in another 18 plus years, the Earth will turn again 1/3 of a way around. So when this eclipse returns in 18 years, that's in the year 2035, it won't be visible over North America. It'll probably be passing over the Pacific Ocean or parts of Asia. But this cycle was known thousands of years ago to the ancient sky watchers, and they were able to make some pretty good predictions just by knowing about the repetition of this eclipse cycle and being able to anticipate when eclipses were going to occur.
So the eclipse that I saw was in July of 1973, because that's how old I am.
Okay.
Add 18 and 2/3 years to that, you get to the 1991 eclipse. Yeah, so that all works out. So Chuck, why don't you give us a question?
All right, why don't we start off? And we'll, of course, we always start with one of our Patreon patron questions because these are the people that support us financially. And
I mean, they bought their way into the question list.
I say it all the time, just like your congressman, we can be bought. So,
Okay. All right.
This is Will Judy. And Will Judy says this.
It's not Judy Well?
Now I'm confused. It could be Judy Well, but it's, or Will Judy.
I don't know anyone with the last name of Judy. That's
Really?
all I'm saying.
Well, maybe I'm saying it wrong because it's Jeudy. So it's Jeudy?
Judy.
Judy.
Okay. All right.
All right. So where are you all going to watch this beautiful event? I will be in South Carolina where there is some great barbecue. Would you mind meeting me there for a beer?
I looked at
So we already discussed the fact that you're not going, you're in a super secret
I'm
location.
a super government secret spot.
Right.
Joe, I think South Carolina has like the least positive weather prospects of the entire trek. Is that correct?
Yeah, unfortunately, places that are near to the Atlantic coast are subjected to a number of things. And if you've ever been down in South Carolina in August, you know, number one, it's hazy. Number two, it tends to be rather humid. And in the afternoon hours especially, which is when this eclipse is going to occur, there tends to be showers and thunderstorms that pop up. So it's not the best place to be. But still, even if you see a total eclipse of the sun and it happens to be cloudy, and that has happened to me once out of the 11 times that I've seen total eclipses, it's still a very, very dramatic sight to see. Of course, you don't want to be deprived of a view of the beautiful corona, the outer atmosphere of the sun that appears during totality. But down in South Carolina, hopefully the weather will be clear enough for you to see that. But again, in the summertime, not really the best weather prospects for viewing
Okay, so Judy, just make sure the barbecue's good. Okay. Next question.
Oh, there you go. All right. This is Eric Varga coming to us from Facebook. I'm aware that the moon is receding from the Earth at a rate of a couple inches per year. How long will it be until the moon's orbit has moved too far to have any more total solar eclipses?
Ooh.
What an incredible question.
So the moon is getting smaller and smaller. That means there will be a day where the moon will never in its orbit be large enough to completely cover the sun.
Right.
They'll still have eclipses.
Right.
They just won't be total.
They just won't be total.
In fact, there's the word for ring is annulus.
Annulus.
That's a word it's of Latin for a ring.
Right.
And so one of the kinds of eclipses is an annular eclipse.
Annular, right.
Right. And where the moon goes in the center of the sun, you see a ring of sunlight. So, Joe, have you done this calculation? I haven't.
There's a gentleman who lives in Belgium who's world renowned. He's a very famous calculator of celestial mechanics, Jean Meus. And Dr. Meus has done the calculation, and he says that sometime about 1 billion or so years from now, the moon will indeed be too far away to create total eclipses. Actually, he says that there's going to be a few million years where it's going to alternate, where it'll be possible and then not possible. You'll get periods where you'll go through periods where the moon will be too far away, and then it'll just be close enough to cover the sun. But in about 1 billion years or so, according to Dr. Meus, that will be the time when eclipses of the sun, total eclipses of the sun, will just be a thing of the past. So enjoy these spectacles while they last, because in about 1 billion years, they're going away.
By the way, for billion years ago, when the moon formed, it was 20 times larger in the sky than it is now.
Wow.
So you would have some serious eclipses no, not an eclipse again.
Right, exactly.
Yeah, I got to finish my homework.
Yeah,
you know?
just like, where'd the lights go again? Who's not paying this bill? Right. Who is not paying this bill?
Yeah, so the moon has been spiraling away over the billions of years.
Right.
But the rate at which it spirals away will get slower. So it was happening fast long ago.
Yeah.
Yeah.
So that makes me curious about eclipses from the standpoint of other planets. So is there another planet where it seems as though we are uniquely situated for eclipses, total solar eclipses the way they happen here? Is there another planet in our solar system that might have maybe a couple moons that do the same thing or that align at the same time, or that might give us some different configurations of an eclipse?
Are you interjecting your own question from the Cosmic Query?
I am interjecting.
Okay, that's allowed because you're co-host. That's fine.
Good.
That's allowed.
Good.
So an interesting fact about the moon and the sun is the number 300, Joe. The moon is the sun is 300 times farther away than the moon is, and the sun is.
I think it's 400.
400. The sun is 400 times farther away from us than the moon is.
Okay.
And the sun is 400 times larger than the moon. So.
Look at that.
Cancel straight out, and they fit. They're free. So, anybody else have that ratio in the whole solar system, Joe?
I don't think so. And there are so many moons now. I mean, when you and I were growing up, Neil, it was so easy. Jupiter had 12, and Saturn had 10.
A couple dozen moons in the solar system.
Now, Saturn alone has like 67 moons, and Jupiter has like a similar amount. But I think all of those satellites that are going around all the other planets are probably too small to create the same type of effect as what we have here. As seen from the Earth. In fact, you might even call the Earth-Moon system a double planet. There's no moon that is proportionally as large a size as our moon is relative to the Earth, as opposed to all the other planets in the solar system that have satellites to create the spectacle of a total eclipse of the sun.
Now, before 2006, we would have said Pluto has a larger moon relative to itself.
Absolutely.
But since it's not a planet anymore, it's not in his answer.
Exactly.
Right, because Pluto's moon, Charon, is even bigger compared to Pluto than our moon is compared to us.
Right. So the size-to-distance ratio for Pluto, if it were a planet, take that ice ball, might make it uniquely situated to experience what
I think, but the sun is really, really small out there.
Right.
So
because it's so far away.
It's so far away.
Right. So either way, it still doesn't really fit.
You get an eclipse, but if the object passing between you and the sun is really, really large, you're not going to get the beautiful corona effect. Because that's right adjacent to the edge of the sun.
It's like just closing your eyes, because it just blocks everything
closing your
out.
eyes,
You just close your eyes at that point.
Exactly.
Wow.
Exactly.
Dude, that was great.
Okay.
Awesome. All right.
We got 1 minute left?
We got 1 minute left.
In this segment.
All right, you know what? So since we got 1 minute left, I'm going to give you a...
What?
Okay, I got to do this because I got to ask you this question just because Andrew Hanks wants to know this, and I'm taking him seriously, okay? Will the sun melt the moon when it passes in front of it? I'm not too keen on cheese, and I don't fancy it raining down on me when I go shopping. I did not make that up. Andrew Hanks wants to know, will the sun melt the moon when it passes in front?
Okay, here's the thing.
I'll take that.
Given how many people think today that Earth is flat,
right?
This is a high-level question. I'm impressed. We're getting better. At least it's thinking about the thermodynamics of the situation.
Absolutely. See, that's why I asked it, because I knew, and no matter what, Neil will find a way to answer someone's question. I don't care how stupid it is, okay? And I know they say there's no such thing as stupid questions, but the people who say that are stupid. So...
All right, so Joe, I'll take this one. So here it is. So on the side of the moon that is facing the sun, it's a couple hundred degrees. It's very hot.
Very hot.
And it will melt almost anything you would eat. Like cheese would just be melted.
Right.
And so if the moon were made of cheese, half of it would just melt off the face.
Right.
Right? So, but now the moon is turning, and it takes a month to turn, turns out, because this matches the time it takes to go around the Earth. So on the side where the sun is not shining, it's like, how cold does it get on the dark side, the unlit side of the moon?
About 250 below zero.
Yeah, below
Fahrenheit.
zero. So that'll freeze it right back up.
Right.
Right. So if you want to live on the moon and not melt or freeze, you want to be in like a rotisserie right at the boundary of light and dark.
You just want to find that line of light and dark and spin around.
Just rotate so the side of you that's baked is exchanged intermittently with the side that's frozen.
There you go.
And that way you stay one temperature.
And see, that's why I asked these questions, because we still learn something after all. Okay.
We're going to take a break. We'll come back to Cosmic Queries on the Great American Eclipse with my friend and colleague and Hayden associate, Joe Rayo, on video call. We'll be right back.
Hey, Chuck Nice here. You know, a total solar eclipse blocks out the sun, so allow me to enlighten you on a couple of things. Did you like what I did just there? Thing one, Playing with Science is a new show under the Startalk umbrella, featuring Gary O'Reilly, a former professional footballer, and yours truly. Join us as we break down the science of sports. It's where jocks and geeks collide without a concussion, and it's loads of fun. Thing two, everything that we do can be found on StartalkAllAccess.com. That's right, in audio and video form. I don't care what it is. If we've done it, it will be on StartalkAllAccess.com. Plus, full interviews that can't be found anywhere else and exclusive original content that we make just for you because you subscribe to StartalkAllAccess.com. So do me a favor, click on the link or click on the link. I don't know where it is. These glasses are blinding me. Maybe it's because they're not solar eclipse approved. I think I'm losing vision. But click on the link and subscribe and watch me go blind. StartalkAllAccess.com.
We're back on Star Talk, Cosmic Queries edition. Special topic, America Great Eclipse.
America.
Monday, August 21st. Dateline 2017. I got Chuck Nice. I got Joe Rayo on video call, an associate of the Hayden Planetarium, my go-to man for everything night sky. And in this particular case, it's day sky.
Before the next question, can I just make one suggestion to anyone who's watching, who's planning to see this eclipse, the first eclipse that he or she has ever seen? A lot of people are going to try to photograph this eclipse. And my suggestion to any first-timer is don't bother taking pictures. You want to drink in every single last second of the total phase of the eclipse. You don't want to fumble around with your iPhone. You don't want to, if you have a camera and looking for the aperture settings or whatever, you just want to sit and watch and enjoy this entire beautiful spectacle. Because I've told people before, Chuck and Neil, trying to photograph your very first total eclipse of the sun is like your first girlfriend. You're not very good at it. It's over very quickly. And you just want to do it all over again. And it's that kind of a thing.
And, okay, since it's like your first girlfriend, do you cry when it's over? Because that was my experience.
All right. I will add that lately people have been using their smartphone to take video of extraordinary events that are in front of them. And so here's something extraordinary in front of them, and they're looking at a 2-inch screen of the extraordinary event.
Right.
So that, in fact, the cost of keeping a video of it is having missed the event entirely.
Absolutely. That's the expense of having that video, is that you actually missed the thing that you were there to see.
It was some event where the Pope was going by, and everybody looking at the Pope through the thing.
Right.
And look at the man that just do, what are you doing?
He's right there.
He's right.
He's right.
Yeah, so maybe you might want to commit this event to your own memory.
I tell you what, here's a suggestion. There are going to be, across the path of totality, along the path of totality, so many professional photographers who are going to photograph the event and video the event.
Right.
Go, watch it, and then buy their photo.
Right. We don't need your wimpy ass iPhone picture.
Exactly. Just go. Just be like, and then put it up, right? And people say, "Oh, what's that?" And like, "Oh, that's the eclipse.
That's the eclipse I saw.
I saw that eclipse." And then you have a record of the eclipse, but from a professional standpoint.
There you go.
So,
all right, next question.
All right, here we go. This is Heath McCasland. And Heath would like to know this, coming to us from Facebook. For astronauts watching from the ISS, will any man-made lights be visible to the naked eye in the umbra of the eclipse? Interesting question.
So, Joe.
Believe it or not, they have already done the computations, and the astronauts on board the ISS will see the eclipse on 3 separate rotations or 3 separate orbits of the Earth. They will not see a total eclipse, but they will see, in the most extreme case, something like an 80% partial eclipse. And when they look down on the Earth, what they will see will be, in essence, what looks to be like a black stain that is projected upon the surface of the Earth, be it on the ocean or as it's passing over the United States. And that black stain, of course, is the moon's umbra, the dark shadow that's going to create the total eclipse of the sun. I think only one time in the history of manned spaceflight, I think it was Gemini 12, 2 astronauts circling the Earth back in 1966, did briefly, for a few seconds, see a total eclipse of the sun as they passed into the moon's shadow. I think one of those astronauts, in fact, was Buzz Aldrin, the second man to walk on the moon. But it's I guess difficult to get the space vehicle involved as it's circling the Earth, getting into the shadow of the moon. But they will be able to see from the International Space Station what's going on down there with that black shadow moving over the Earth, and up in the sky with the moon passing across the face of the sun.
So, Joe, how fast is the shadow moving on Earth's surface?
Well, the moon goes around the Earth at a speed of about 2,300 miles per hour. You would think that would be the speed as it's moving across the surface of the Earth, but that's not true, because we here on the Earth are on a turning Earth.
Yeah.
And so we are moving, and we are, in some cases, staying with the shadow for a period of time, especially if the shadow is passing over the equatorial regions. We could stay with it and help to slow the movement of the shadow across the Earth down. In this particular case, the shadow, as it goes from coast to coast across the United States, will be moving roughly at an average speed of about 1,600 or 1,700 miles per hour. It'll be moving actually a little slower over Tennessee and Kentucky, and a bit faster as it's entering the United States from the Pacific coast, but still a rather rapid speed. And even if you had one of those supersonic transport planes, you wouldn't be able to stay in it forever. The moon eventually is going to win out with that fast movement.
One of my favorite things to look for, particularly in eclipses where the shadow is not as big as the one that I had seen, so the eclipse is shorter. My favorite thing is to watch the shadow approach from the horizon.
Nice.
Moving at 1,700 miles an hour. It's this cut through the atmosphere, and it is dark in the center, yet it is twilight on each side of it. And here it comes. It goes, and then no one's going to be looking at it because they're all going to be looking up. But the old timers who've seen 10 a dozen eclipses, the greedy ones, we know the other stuff to look at.
Right.
That's what the sideshow that makes up the total circus that this is.
Sweet.
So what else you have?
All right, here we go. Jeff, Starcheck wants to know this. I'm sure I butchered your name, Jeff.
This is if you didn't, we would not know who you were. Okay. All right.
Here we go. Jeff wants to know this. Does the solar eclipse give our ground-based telescopes an enhanced view of distant objects due to gravitational lensing? So is there any enhanced view of what we're looking out past during the eclipse? And isn't that how we prove Einstein right about his...
You remember this in the year 1919.
Correct.
Sir Arthur Eddington led an expedition to test this 3-year-old prediction that gravity would bend the path of light. So severe gravity would bend it noticeably. And they wanted to do it in an eclipse in 1918. But the First World War the Great War was still interfering with material and personnel movement. So they had to wait till 1919. And sure enough, they made the measurements. The stars whose light passed near the edge of the sun, which you wouldn't otherwise be able to see in the daytime,
right.
or when you're not in eclipse. Right. So the positions of those stars were slightly different than when they were 6 months later, when you would observe them in the dark of night. And that bending confirmed Einstein's general theory of relativity.
Right.
So that's exactly how that played out.
Super cool, man.
Yeah. What else you got?
Super cool stuff.
Give me some more.
All right. Alan Pelasco from Facebook would like to know this. Hey, Neil, can you please explain why there is no dark side of the moon and why it isn't all dark?
Those are the last two phrases in Pink Floyd's Dark Side of the Moon song of the Dark Side of the Moon album from 1973.
Oh, really?
Yes.
I did
At
not.
the end of that song, it says, "There is no dark side of the moon. It's all dark."
Oh.
But it's the way, you got to listen. You got to that's a headphone moment.
Yeah, because
okay?
I've heard the song.
Yeah, just check it out
I gotta check
again.
it again. Okay.
So I have weird memory of cosmic references in the history of rock and roll. Okay.
Nice.
So so the moon only ever shows one face to us.
Okay.
There is a far side and a near side for that reason.
Right.
But all sides of the moon get sunlight. A day on the moon, daytime in the moon is about 15 days long, and then 15 days of night. So it's a long day, and when it's night for 15 days, but it's not eternally dark. So it is a misunderstanding, and I blame Pink Floyd for that. I had to undo. They're way more influential than I ever was, just in naming their. So you know who got it right?
Who got it right?
The cartoonist, Gary Larson. What was the name of his cartoon?
It's called Dark Side.
No.
Right? Wait.
The Far Side.
Oh, the Far Side. Dark Side.
See, there's a scientifically literate person referencing.
The Far Side.
Yeah, because there is a far side and there's a near side.
Gotcha.
There is
and
no
the
dark
reason it's
side.
a Far Side and near side is because it's tidally locked.
Tidally locked. Right. It's always.
So
it is turning.
It's turning, but it's just showing us
at
that
exactly the same rate that it takes to go around. We tidally locked in.
Okay. So we slowed the moon down.
Yeah, the moon was spinning like anybody else in town.
Okay.
We slowed it down, and now it's locked, and it will stay that way forever.
Wow.
It's trying to tidally lock us.
Okay, wait a minute. Now that we can't stand for.
We can't stand for that.
No.
But it'll take longer to do that than the expected age of the sun, the life expectancy of the sun. So we cool.
Okay, good.
Okay. What else you got?
All right. John Reinhold wants to know this. Will there be a measurable air temperature difference during the eclipse?
Joe.
Yes, there most definitely will. In fact, in the middle part of the country, where it will be happening at midday, or actually in the eastern half of the country, where it'll be happening like 2 or 3 o'clock in the afternoon, if there's enough of the sun covered, 80, 90% or a total, you could get a temperature drop of 3, 4, 5 degrees or more. And as the air actually begins to contract with that cooling of the atmosphere, that helps to pull in the winds from all directions. That's why sometimes when you get the midpoint of a major eclipse, a cool breeze suddenly starts to spring up. So most definitely, maybe not so much in the western United States where it'll be during the morning hours, and there hasn't been enough heating taking place yet, but most definitely in the middle part of the country and in the eastern part of the country, you will get a noticeable temperature drop around or soon after the point of mid-eclipse, maximum
And it's
eclipse.
not only an actual air temperature, there's also, once the sun is blocked, you're no longer getting radiant heat. Okay?
Right.
You ever notice if someone walks between you and a fireplace, you feel instantly cold?
Absolutely.
Well, the air temperature is the same.
That's true.
The air temperature didn't all of a sudden change in that instant.
Oh, it's the heat emanating from the fire.
It's the photons coming from the fire touching your skin and getting absorbed. It has nothing to do with the temperature of the air. So you blot out the sun, you not only get the cooling that Joe's talking about, you get the absence of photons that you had been basking in. This is why shade is cooler than non-shade in the summertime.
Right.
It's the only reason why.
It's just blocking those
It's
photons.
just blocking this extra source of heat to you.
Right.
The shade is not really cooler than being out in the sunlight.
Yeah.
If you're walking in and out of the shade back and forth, the air is all mixed.
I can't wait to lay by a fire with my wife. The next time we'll be like, baby, that's not heat. That's my photons. You feel that, girl?
You feel my photons?
You feel my photons, girl?
I've got time for one more.
All right, here we go. Here we go. This is actually important. James Cultus asking a very important question here. Hey, Neil, are you going to watch the eclipse in person? Which we know you are. If so, and Joe can chime in on this too, please tell me what gear you will use. Should we watch through binoculars, telescopes, glasses, wine? Just hold your glass of wine up.
Joe, we didn't spend any time on this. Give us some concluding comments on what's the best way to view the eclipse.
Oh, well, the best way, everybody has been scrounging around for eclipse glasses. And in fact, believe it or not, now there are knockoff eclipse glasses. These glasses are made either of mylar or a special plastic called polymer, and they have been tested. They have been certified, but there are some places that haven't been certified that could have a scratch in them. You have to be very, very careful with that. A lot of these knockoffs have suddenly appeared over the last 3 weeks. You don't have to look directly at the sun, however. If you do, you could also use welder's glass. number 13 and number 14 welder's glass. You can get that at any hardware store or welding supply store. It'll turn the sun green when you look through it, but it will be enough so that you'll be able to see it safely. It blocks out both the visible, infrared, and ultraviolet radiations. But if you don't even want to look at the sun directly, you can just find a shade tree. I think this is most delightful. The light going through the spaces in between the leaves project or dapple the ground with hundreds of these images of the sun on the ground. And if there's a light breeze, they almost seem like they're twinkling. It's the same methodology as when you're doing a pinhole image of the sun. You let the sun's light go through a pinhole, and then you hold a card or a piece of paper about 2 or 3 feet away from the pinhole, and you can see the image projected on that screen using the pinhole image. The trees do it for you naturally. And by the way, you could also use a mirror, believe it or not. If you have, like, let's say, a compact mirror or a small mirror, just punch a hole in a piece of construction paper, put it over the mirror, and then turn the mirror to the sun. You can project that image onto, let's say, the side of a house, and it will project the exact same image that's happening up in the sky. Another very safe way of looking at it. You don't have to worry about blinding yourself. You just look at that projected image using the mirror. So there are a number of safe ways. Don't look at it with sunglasses. Don't look at it directly. Don't use smoke glass. That just transmits the ultraviolet infrared radiation into your eye. And since your eyes can't sense pain, your eyes, if you're looking through a piece of smoked glass, for example, are being fried without your being aware of it. You'll learn about it later when you see a hole and you can't see anything anymore in that particular spot where you were looking at the sun. During totality, look at the sun directly. That's the only time that you can look directly at the sun during an eclipse, is during totality. You know, Charles Schulz, bless his soul, the man who created Peanuts, back in 1963, he did a 6-story arc of comic strips with the Peanuts characters looking up at getting ready for the eclipse. And Linus, and you remember Linus, who was always the voice of reason among the Peanuts kids, he said in one of those comic strips, it's dangerous to look at the sun during an eclipse, and especially dangerous when it's a total eclipse, giving the impression that the worst time to look is during totality. Linus, you're wrong. You can look directly at the sun during the total phase only of the eclipse. That's the time to take your eyewear off, put down the projected cards, and look directly up at the sun. That will give you a spectacular view, but make sure that when the sun begins to emerge, that you put those glasses back on again, because, again, even that slight little sliver of sunlight is still dangerous to look at.
But in all fairness to Linus, the reason why he thought that is because Snoopy looked at it before it was in its totality, and that's why he wears those sunglasses, and they call him Joe Cool. It's not true. He's just blind.
He's just
blind.
A quick couple of tidbits just to end the show with.
Go ahead.
The 2 parts of the shadow, the darkest part is the umbra. That's totality, and the surrounding area is the penumbra, which is where part of the sun is covered. Umbra is the same Latin root that we use for umbrella.
Nice.
Umbrella.
Umbrella.
And umbra are related words.
Yes.
That's cool.
That is cool.
Yeah. Not only that, as the sun gets more and more eclipsed, and there's a thinner and thinner sliver, the source of light becomes more point-like. And we take for granted what our shadows look like on the street.
Right.
They all have fuzzy edges.
Right.
You don't think about it because that's just your shadow. As the sun gets narrower and narrower, it will cast a shadow the way stage lights will cast a shadow with very sharp edges. And all of a sudden, this is what Joe alluded to earlier, there's an eerie effect that takes place around you. Shadows look different. They're more precise. They're sharp. They're eerie. You're in an otherworldly landscape during these last few moments of the eclipse.
Man, that sounds like an LSD trip.
Then, that last little bit of the sun, Joe, what do we call that? That last little bit?
We call it the diamond ring.
The diamond ring.
Or the last, or Bailey's beads.
Bailey's beads? Or, I like diamond ring.
Yeah, there's ointment for that. What I'm talking about. So the diamond ring effect is that last little bit. It's bright on top, and you can still see the outline of the moon, so it looks like a wedding ring.
Right.
Yeah.
That's
an engagement ring.
An engagement ring. Yeah, that's cool.
Joe, we got to end it there. Thanks for videoing in to Startalk.
Thank you for inviting me, and good luck to all who are going to be at the eclipse on Monday, the 21st.
Joe, it doesn't take luck; it takes knowledge. Anyway, Chuck.
Hey.
Love you, man.
Oh, I love you too, man.
All right. You've been watching, possibly listening to Star Talk, and we've been recording this live at the Mashable World headquarters, the Mashable Universe headquarters in New York City. I've been your host, Neil deGrasse Tyson, Chuck Nice, Joe Rayo on video. I've been your personal astrophysicist, and until next time, I bid you to keep looking up.
Hey, if you like this, please remember everything that we do can be found commercial-free, plus exclusive original content, all on StartalkAllAccess.com. .com.